Okay, so this set of notes is going to be on mining. So this is the Unit 5, Section 9, mining notes. And let's wait here for the PowerPoint to pick up. And so let's talk a little bit about some of the basic vocab terms that you need to know in terms of mining. So the first is ore. Ore are commercially valuable deposits of concentrated minerals that we can harvest and then we can use as a variety of raw materials. And this is extremely important for industry and manufacturing. And then metal, I think you probably all know what a metal is, but just in case, a metal is an element that conducts electricity, heat, and has structural properties for building. And we tend to find metals within various ores. Okay, and so you can see here, this is what we are going to be mining through this rock. This rock is full of different elements, either metallic elements or a combination of metallic elements that we call ore. A reserve, this is the known amount of a resource that's left that can be mined. So we might talk about having a coal reserve, having a aluminum reserve, having a steel, well, not steel, but having an iron ore reserve, okay? And so this is usually measured in how many years we have left of extracting at our current rate. And so reserve, that's just another word that you need to know. Overburden is the soil, the vegetation, and the rocks that are removed in order to reach the ore deposit. And so anything that's like not considered to be the metal or the ore itself is considered an overburden. And then lastly, we have things that are called tailings and slag. These are basically the leftover waste material that's separated from the valuable metal or the mineral within the ore. And we often store these in ponds, or we might just store this at the mine site itself. And this is actually stuff that we need to actually put back at the end of the mining process. So we'll talk a little bit about that in a few minutes. Okay, so let's talk about some various mining methods. So the first is surface mining. Surface mining is the removal of the overburden, so the other stuff that is there other than the ore itself. And so we have to remove that so that we can actually access the ore near the surface. Again, this is called surface mining because we're not going very deep into the earth. There are different types of surface mining. We have open pit. We have mountaintop removal, you'll see here in the picture. And then we have placers, where we'll go in and mine just a specific area. So mountaintop removal is especially damaging to the landscape. It's damaging to the habitats. It's damaging to nearby streams. Because basically you're removing the vegetation and the soil. There's a lot of topsoil erosion that occurs as a result of surface mining. We end up losing a lot of habitats for those animals that lived there previous to the mining excavation that occurs. And because there's a lot of erosion, there's an increased stream turbidity. The cloudiness of the streams increases, which we've already talked about the negative impacts of that. And it also, as you can imagine, because there's a lot of erosion, you're going to be increasing the particulate matter count that we find in the air, which is not a good thing for folks with sensitive respiratory tracts. As the ore near the surface becomes more scarce, the mining will end up moving deeper and deeper underground, and it will actually begin to turn into something that we call subsurface mining, which is a much more expensive process. Subsurface mining is when we think of like old coal mines that we used to have, where you've got these shafts that you have to go down underneath the ground. There's like an elevator that will transport folks to the much deeper layers of the earth to collect the ore. Okay, and so let's go ahead and talk then a little bit about subsurface mining. And so it is much more expensive due to the higher insurance and healthcare costs for the workers that the company has to purchase. There's a lot of risks with subsurface mining, which includes poor ventilation. This can lead to toxic gases building up in a mine and then exposing the workers to the toxic gas. The risks that are involved with subsurface mining also include, worrying about a collapse of one of these mines that are below the surface, injury from rock that might just happen to fall off. And then because you're dealing with a lot of dangerous materials under the ground in a small area, there's going to be a lot of breathing in of this dangerous gas and particles. And so that can lead to lung cancer. You can also be exposed to asbestos, which is a type of clay that gets embedded into your lung tissue, which also leads to lung cancer. You can have fires that occur underground, and you can even have, if there's a buildup of gas and then there's some sparks that start an explosion, that can be a real issue as well. And so with subsurface mining, there's always some type of a vertical shaft that's drilled into the ground, and then an elevator is installed to allow the miners and the miners to get into the shafts or into the mines, and then the coal to get out of the mines. Coal tends to be the most common form of subsurface mining that we have because it is so deep in the ground. It's increasingly used more and more throughout the world because as our surface coal deposits are depleted, we're having to go further into the ground to find coal. And so what are some of the environmental impacts of mining? Well, the first environmental impact from mining that we have is something called acid mine drainage. This is when rainwater leaks into abandoned mine tunnels and it mixes with the materials that are already there. Like it mixes with the pyrite, which is there, which we tend to call that, if you've ever heard of fool's gold. It's a rock that looks very similar to gold. It has a gold shiny look to it. But when the water and the oxygen combines with pyrite, it forms something called sulfuric acid, which I'm sure you're familiar with. And so this is a real problem in mines because that sulfuric acid then can get carried away into nearby streams. It can infiltrate groundwater, and what it does is it lowers the pH. That sulfuric acid lowers the pH of water, which makes toxic metals like mercury and aluminum potentially more viable, like to get into our drinking water or even into aquatic organisms' habitats, which is very dangerous for food webs. Can also be dangerous for us if it gets in our drinking water. And then in other environmental impacts with coal mining specifically is that methane is released from the rock that's around the coal. And so this methane gas can get vented out of the mine. If it's not vented properly or too much of it builds up in an area, it can actually cause an explosion. And even after mines are shut down, like once we're done mining a mine and the mine is closed, methane continues to like seep out of the rocks that have been disturbed. And so this is just a real problem because methane is considered a greenhouse gas. And so this then gets into the atmosphere as well and just contributes to our issues with climate change. Other environmental impacts of mining include particulate matter being released into the atmosphere, like we already have talked about with other agricultural practices as well. But in coal mining especially, there's a lot of soot and dirt that gets released and lots of other particulates that can irritate both human and animal lungs. And there is even some very dangerous stuff, like I talked about with asbestos, that can get embedded into our lung tissue and then eventually lead to lung cancer. So that's a real concern for coal miners especially. All right, some other negative environmental impacts include the topsoil erosion, as you would expect, habitat loss, and then increased stream turbidity. So, one thing that is required of all mines now is that you have to reclaim the land. And so, what mine reclamation is the process of restoring land to its original state after the mining is finished. So, this includes, filling the empty mine shafts and the hole that you've dug into the earth, and then restoring the original contour of the land. So as you can imagine, this would require like civil and environmental engineers to come in and recreate the landscape that was there previously, essentially. So you're returning all of the topsoil, you're returning all of the acids, the metals, and the tailings that were removed. You're replanting the native plants that were there to actually restore the community. So you really have to survey the land. Companies have to invest in surveying the land before they mine the land now so that it is returned to the most original state that it can be returned to as possible. And so this, as you can imagine, is not just completed out of the generosity of the company's, goodwill towards the environment. It's actually a federal regulation, and there was a Mining Reclamation Act that was passed that is, where all of this has to happen. So the mining company has to actually go through this process of reclamation. So that's important to know. Okay, it's time for our practice FRQ 5.9. An abandoned coal mine site has been found to have high sulfur levels in the tailings and the overburden left at the site. Describe one environmental impact of the high sulfur content of the overburden and tailings, and propose a solution to remedy or reduce this impact. Okay, next up will be 5.10, urbanization, and I will see you guys next time.